Hi, this is Pat Moorhead with More Insights and Strategy, and we are here for another More Insights and Strategy podcast. And we are here with folks from HPE Greenlake and NVIDIA, and we're going to talk about how Greenlake is shaping the future of the cloud with AI and machine learning. Exciting stuff. And Alaric and Srikanth, if you can maybe introduce yourself, that would be a great place to start.
Hey, Pat, thank you. My name is Alaric Thomas. I'm a product manager working in HP in the Greenlake group. I'm responsible for actually two offerings. One is a data science platform as a service called Greenlake for MLOps. And a second is a data fabric as a service, also under the Greenlake umbrella. Thanks, Pat.
It sounds great, and congratulations on all the progress you're making with Greenlake. It's impressive. Shri, how about yourself? What do you do for NVIDIA?
Yeah, thanks, Pat. My name is Srikanth Vijayaraghavan, and I'm part of the global account management team at NVIDIA that works closely with OEMs. Specifically, I have responsibility for HPE. And I focus more on NVIDIA's enterprise software portfolio, taking that, solutioning that along with HPE's offerings and bringing that to market.
This is great. Very impressive. I've been tracking NVIDIA for decades. In fact, my first introduction to NVIDIA was in 1996. So I'm aging when I was a product manager at Compact Computer. So it's been an amazing run that you guys have had. So, hey, let's dive right into this. I think a good place to start, and Alaric, maybe we'll start with you, is can you talk about how customers, their AI and ML workloads are evolving?
Yeah, indeed. The data science world continues at a pace, and as a product manager, I'm in a fortunate position to be able to get access to customers and prospects who are looking to deploy AI ML on-prem and or indeed in the cloud. There are three sort of trends or three sort of paths that that questions come from at the moment. The first is an old topic. It's always around. It's around pricing. It's around costs, and it's about. Typically, recently, it's been more about how can costs be more transparent with these AI ML services. What's typically happening is the customer might pick up an AI ML service. It might look to be well priced, and they understand how they consume, and what they do is going to generate costs against this service. But then they find that there are multiple other services that they have to bundle in to meet their end-to-end use case, and so that's a frequently occurring topic at the moment. Second, I can pick on would be more around the support of the end-to-end process, the end-to-end data science lifecycle process. So today we see a lot of good tooling out there for the model building, the investigation, the model building, the training, deploying, testing. Use cases, but then at the ends of the data science workflows. So one end would be your model goes into production, and so you want to monitor that model. You want to see, is it firstly from a resource perspective, what's it consuming? But then the slightly harder problem and very use case specific problem is, well, how accurate is my model? And is my model actually drifting away from reality? Are my predictions now drifting from what's actually happening? And so we're trying to help our customers today actually with frameworks to answer some of those questions. So that's definitely a regular topic. And as I mentioned back at the sort of the beginning of the life cycle as well, it starts with data. Yeah. So data is used all the way through the model build process and the training process. And invariably, the data scientist is going to be asked at one point, how did your model come up with that prediction? How did you get that number? And to answer that question, the data scientist has got to recurse all the way through, their data science pipeline and the many transformations that have gone on from actually the source data set they get. And so providing a framework to answer that question comes up a lot also. Along with that, the data lineage question is data governance. So customers are struggling with that today. We're trying to find ways to help them. And then the third thing I would pick on would be resource management. How do customers make good use of the resources that are available to them in these data science platforms? And really, they're going in two directions. One is they've got more data science workloads that they want to run than they have, say, GPU resources. And so how do they split up that GPU resource to support multiple workloads at any one time? So the conversation goes down fractionalization. And then the other side of the conversation is they have a model that they want to train, and that model won't fit, or the training data won't fit in the memory of one GPU. So how do you parallelize your GPUs and the memory associated with them to train a model at higher levels of accuracy? So those are really the trends that I'm observing as I have customer conversations at the moment. So a lot of really interesting stuff and places where we hope to be able to help our customers.
Yeah, it's incredible. The more we learn, the more the challenges come out. It's wild. But then again, more people are getting more done with AI and ML than ever before, because we acknowledge the challenges and the industry has responded with that. I'd like to turn it over to Sri and ask him a bit of a loaded question here. I mean, first of all, is there an optimal AI infrastructure? And if there is, what is it?
Yeah, thanks, Pat. I think first, we have to sort of set up the problem to some extent. If you look at AI ML as a workload, obviously it's slightly different from a typical enterprise workload. It is merging to some extent, in how it is run and managed. So I always like to think of this in three pillars, if you will. The first problem that we need to solve is how can you manage this infrastructure like you would manage anything else in the enterprise? Because if you look at historically the evolution of this workload, AI was always thought of as, hey, this is this big supercomputer sitting somewhere in a corner that's cracking numbers, right? So we have evolved so much. It's part of many little things. Your word completes your sentence and so on, right? So we know AI is pervasive in enterprise workloads, which sort of ends up with the expectation that it should run on mainstream servers that is used for any other enterprise workloads, which also means, hey, how can I manage this as one unified entity and not have specialized infrastructure sitting somewhere, right? So IT ops, huge requirement. The second pillar that I always think of is as an enterprise who is starting the AI journey, it's not very easy to, and I think Alaric hit on some of these points. It's not easy to just go Google and find what you need and get an AI workload going. So anything that we can do in the industry with companies that have expertise that says, here you go, here are the 5-6 things that you need to get started right away, that takes you from experimentation to production quickly. How can you give you that set of AI libraries that's tested and proven? Right? That's really the second important requirement that we have to solve. And the third piece is very foundational, which is the hardware infrastructure, right? So yes, to run AI ML, the hardware infrastructure is slightly different. It needs a little bit more. It's a high performing infrastructure. So giving customers exactly what they need, taking the guesswork out. So we fine tune that hardware infrastructure is the third piece of it. So these are really 3 requirements that feed into what makes the optimal AI infrastructure. And if you put it in that framework, we can sort of build it up. And a lot of the challenges with AI ML that Alaric talked about sort of builds on it. Obviously most important is the hardware piece, which I talked about. Is it optimal? Is it performant? Does it have the right networking and bandwidth requirements? Does it have the right GPUs? All of that goes into that. The next piece is how we are going to manage it. Specifically for AI ML, you want a management and orchestration layer that is very, very hardware aware. Virtualization has been around for a long time, which is reasonably hardware aware. So this takes it one step beyond that, because now you have GPUs in the play. So having a management and orchestration layer which understands this AI ML hardware and is being able to resource that is very important. And when you talk about this, automatically then you think about scaling, right? Okay, 1, 2, you can do it. If you scale, you build a cluster of this. How do you manage that cluster? Certainly, that is another piece that comes into mind. And it's not like people have not done this in the industry. They have been doing this for a long time. But doing this in the context of AI ML adds a lot more complexities. Some of the things that we just discussed, as in data, model, training the model, productizing it, deploying it. So extending the DevOps methodology into something that we refer to as ML Ops, which brings in some of the ML workloads specific aspects into that DevOps model. That layer needs to sit on top of the hardware and the management orchestration layer. So that brings everything together. Of course, the last piece, which where NVIDIA has a major investment in is the containers, the applications that you actually use to go execute on this flow. You need to have a robust, something that can take you to the promised land as quickly as possible, if you will. These can take, if you don't have the right things in place, like Alaric said, it could have the wrong prediction, or it could take days to get the wrong prediction. So you want to have the right set of libraries sitting on top. So that's sort of going back: hardware management and orchestration layer, ML ops, something that manages the cluster well, and the suite of apps, AI apps that sits on top is really what I would summarize as an optimal AI infrastructure.
It's as simple as that.
As simple as that, yes.
Exactly. So, Alaric, you talked about the evolution of the workloads, and Sri, you talked about the 5 different pieces that come together for an optimal AI infrastructure. Now, I think we should talk about how the wonder powers of HPE and NVIDIA come together to make this happen. Maybe drill down a little bit more into that, and maybe Sri, I know you just talked a lot about that, but I think a good place to start would be on the hardware side.
Yeah, definitely. And I think this is very interesting, because this is where the power of the two companies really come together. Because these layers, we bring a lot of value in some of the layers, and HPE brings a lot of value in other layers. So maybe it'll be a give and go, between Alaric and me. But starting with the hardware, really, what we have done is we have worked very closely with HPE. So maybe a year or about a year and a half ago, we introduced something called NVIDIA'S certified systems. And this is actually a really cool idea, because it takes a lot of guesswork out for customers. So what we have done is put together a series of tests, both from a performance and a functionality perspective. So we hand over these tests to OEMs, and then they run them on their servers. And basically test the servers for how can you manage them properly, are these apps running securely, and of course performance is a huge part. And the interesting thing is it has a lot of tests that actually mimic real world examples. There are actual analytics workloads, there are things like intelligent video analytics and what have you. So it mimics a lot of these real workloads that customers will use. And once you run through them, basically you've made the life of our customers very easy, because now the acquisition process of getting the right hardware is very easy. HP has a huge, portfolio of impressive servers, and we have I think I have lost count now, but it's double-digit NVIDIA certified servers that we bring to market together. And then I think Alaric probably would like to talk about the orchestration layer on top.
Yeah, indeed, and from my perspective with the data science platform that I product manage, we benefit from a lot of the standards that NVIDIA's put in place, the standards that are out there in the hardware world, and then exactly as you said, Sri, we take advantage of those all the way up the stack. And so having data science applications that can directly address the GPU, move data rapidly onto the GPU is key for us. Just to give a quick example of the standards that we enjoy, PCI was the standard interface to plug your GPU into your motherboard. Yeah. NVIDIA's come out with way improved, our testing showing up to 10x faster throughput with the SXN design. So, starting with that base of standards and then building that up all the way through the stack is very important to allow the orchestration of these very complicated pipelines with multiple tools coming from multiple places, not only from commercial vendors, but also thousands of developers in the open source community. So identifying standards and using those standards all the way up through the stack means that we can make all of these components work together.
Yeah, Sri, why don't you talk about the applications, the libraries, and the containers as part of the Wonder Twins Power Unite. So,
this is we could talk about this all day long, Pat, but we'll keep it succinct here. I mean, if you listen to in our CEO Jensen, he always talks about how we are a full stack company, right? So we are not just a GPU company. So everything that goes, from the hardware, from the middle layer to all the way up to the apps, there is extensive amount of software that is involved. Even in the middle layer for improving performance, we do a lot of stuff. We love the GPU to GPU communication. We love the GPU direct to storage and GPU direct to memories. All of those, adds some level of performance. But then, the icing on the cake, literally, if you look at the layer cake, is the NGC catalog, right? And this is really a godsend, if you will, for many people who are trying to start this AI journey. You have this extensive library of models, which are, some of them are actually, pretty use case specific, but these are developed by experts. These are trained by experts, and they are, maintained as state of the art continuously, and people have access to it, right? And when you start with a pre-trained model and taking you to actually deploying that, it reduces your time to deployment so much, because it takes a lot of stress out of this process, right? You start with a pre-trained model, you need less data, the amount of time you have to train goes down, and so on. So really, the power of NGC catalog is great, and the ecosystem is very big. And what we are doing is we are bringing all of these could be brought into HPE's environment of management and orchestration, and you'll be able to deploy these libraries easily within HPE's environment. And we have done some work recently, specifically on a couple of areas. Rapids is one of our major framework that we use specifically for accelerating data science. We have done a lot of work with HPE in integrating that into their tool set. Similarly, on the deployment side, Triton is our inference server, which basically takes your optimized model that's ready for deployment and allows you to scale it, across data center to edge to wherever it is. So a lot of these have been integrated into HPE's environment, making it that much easier.
Yeah, I appreciate those comments. And while, if I look, gosh, I forget which GTC conference I was at, but I think it was the University of Toronto. It was back when machine learning training was essentially a university type of exercise, and there was improvements on ImageNet, which was picking the right images for somebody who's searching on it. Now here we are, where it has been the public cloud only, and only the largest companies, to enabling enterprises to help do some three basic things, which is increase their revenue, lower costs, or let's say increase the stickiness and loyalty of their customer base. But there are still complexities on that journey. And I'd like to throw out to the two of you, what are some of the challenges for a typical enterprise? And while I know there isn't a typical enterprise, we can't have a conversation about 15 different verticals and sizes. So maybe, Alaric, I'll toss this one out to you.
Yeah, indeed, complexity is complexity is a big topic, and pretty much anywhere you look with data science and the complex workflows and pipelines that need to be supported to build accurate models, complexity is the challenge. Let's take an example. Say you're trying to deploy models at the edge. The tooling that you need to do that, there is no sort of silver bullet tool you can pick up today that says, okay, I'll take a model from a trained model, I'll put it through a test cycle, I'll go to deploy it at the edge, I'll then manage that life cycle at the edge, maybe I'll do additional training at the edge. There is no one set of technologies that you can pick up to do that. So a customer that has that type of deployment requirements is going to have to build something relatively custom today. So they're going to be assembling a large number of mainly open source components that run in multiple places. And so the work that's needed to firstly put in place the architecture to do that is a significant amount of work. It takes firstly a lot of research of the various components that are needed. Then it takes a lot of work to make sure that those components all work together in a consistent stack. Then indeed they can address the GPUs correctly. They can get deployed on the compute resources that you have at the edge. And then after you've done that design, the next thing to do is to keep it up to date. Things are changing all the time. The data science world and data science tooling has the velocity is impressive. There's the sort of standard data science frameworks, the cadence of, say, Kubeflow, which is one of the Kubeflow, MLflow, the sort of standard data science frameworks out there today. The cadence of Kubeflow is every 3 to 4 months, a new release comes out. And so when that happens, that can then have ramifications all the way through your stack, from storage and compute all the way up to the components that you thought you were happily running on the previous version. So just the complexity in managing, firstly, delivering the stack, and then managing the change across all of those many components, I see as a real challenge for companies that are trying to get going with AI, and in fact just trying to meet the bar with their competitors who are already doing some of these things. Sorry, go ahead.
Oh, no, please, no.
And then one other thing I was going to mention here, and it's sort of it goes back to one of the earlier points, was how are customers actually paying for all of this, and how do they want to consume this? And what I'm finding is, and I am building out a data science as a service offering, but the customers that I talk to and the ones that are interested in this sort of service are saying, okay, I can see that you're producing this platform for multiple people, you can do it more efficiently, and you get economies of scale and things, and so they then want to consume this. And the consumption model that they want is, they do like the cloud-like consumption model. They do want the transparency across the service that you provide, so they know that they're not going to get roped into paying for additional services. And so that is another area of complexity that actually needs to get built into the solution from day one. So making the consumption model very transparent and simple is another area of complexity that at least we see we need to help in.
Sri, is there anything you would like to add to that?
I think, yeah, those are some great points, with respect to complexity. And this is why, going back to, the earlier topics of what is an optimal, AI infrastructure, that's some of that, Alaric brings to light. And then on top of that, what does it take for someone to go build it on their own, or, is there a better way to actually acquire this? And even better, is there a better way to first experiment with something that is easily available? And, when you know what you're doing, how can I scale it very quickly, right? So I think Alaric mentioned this from a GreenLake perspective. It allows you to do all of the above, right? Because it has a full stack AI infrastructure that they're offering, HPE is offering, and allows customers to start small, experiment, if that's the stage where they are in, and once you get a hold of it, it's easy to scale. So I mean, consumption is obviously a major part of it. While there is a lot of talk about hybrid cloud as the de facto standard of how enterprises are acting, we all know that there are workloads which still are sitting on premises and are probably never going to move. And specifically with AI ML, the big elephant in the room is the amount of data that you're dealing with. It's not just easy to move all these huge amount of data back and forth. And like Alaric mentioned, it's not a static process, because you're constantly reiterating on this process. New data comes in, model drifts, you're going to train it again. So it makes a lot of sense to have something like this on premise, which is more effective. And on top of it, if you also consume that as a service, it allows you, it gives you that room to experiment and scale.
Yeah, 10 years ago, my analyst firm was one of the first to talk about the hybrid cloud. We called it the private cloud that extended to the public cloud. We certainly weren't public cloud deniers either, but I feel like the entire industry, at least the tech industry, is on the same page that the future is hybrid. You have traditional on-premise companies who are extending to the public cloud. You have the public cloud companies that are offering on-premises offerings as well. So I think we can all agree that it's a very hybrid world. The interesting thing about it is that some enterprises haven't necessarily kept up with that and are only doing certain workloads, AI workloads in the public cloud, which always kind of seemed, I'll call it interesting, because the data is typically not generated in the public cloud. Typically the data was generated on premises or on the edge. So I'm looking forward again to your combined two companies' superpowers to make this happen. I'd like to give each of you the last word, and maybe Sri, we can start with you. Any words of wisdom to enterprises on AI and ML workloads, and Alaric, I'm going to ask you the same question.
Yeah, I think the one word that comes to my mind is planning. Really, this is not something that you can stand up overnight, but there is a lot of help available. Certainly, HPE and NVIDIA would love to help you in this area. That goes without saying. But having a thorough planning, going back to that, what are the key ingredients, understanding the ingredients, and being open to experiment a little bit, and then finding out what is the right solution for you, and then scaling is very important. So if I bring it all together, the combination of the capabilities that NVIDIA brings, and that integrating that with HPE's GreenLake, makes it a wonderful combination to do all of the above, to experiment, to plan, experiment, and scale.
Excellent. Alaric, how about you? Any final words of wisdom for enterprises out there for AI and ML workloads?
Right. Thank you. Yeah, and I would and second what Sri is saying there, and the thing that I'd expand on is, as part of planning and saying, if you're going to do this yourself and you want to build your own stack and you're committed and you have the resources, I would say try and put stakes in the ground. You have a fast-moving community developing and delivering tools and new technologies all the time, and it's very tough to consume them and keep your environment secure, and keep your environment scalable, and so try and get some stakes in the ground. You're obviously going to pick NVIDIA GPUs, build up from your NVIDIA GPUs, build up from some other hardware components, pick your containerization platform, and then pick your framework, and then try and keep some stakes in the ground around that and build out around there, and then evolve your environment from there. That would be my advice.
No, that's great. So Alaric and Sri, I just want to thank you for spending time here on a More Insights and Strategy podcast, and really appreciate the two companies together and making this happen for enterprises. HPE Greenlake, first mover on as a service capabilities, and NVIDIA, obviously first mover, market leader as it comes to machine learning, training, and inference. So it's great to see the two companies working hard to help enterprises out. So thank you so much, and hopefully we can have you on again.
Cool.
Thank you so much, Pat.
Excellent. So this is Pat Moorhead with More Insights and Strategy, signing off for another episode of the More Insights and Strategy podcast.